Good morning, good afternoon. Thank you for joining us for Mastering Asset Level Granularity. Today, Jared and our group product manager and Vijay, our lead engineer for Asset Explorer, are going to be presenting on how asset visibility will change how you do FinOps. Couple housekeeping items real quick. At the end of the webinar, you will see a QR code. That QR code will take you to our community page. If the queries that Vijay and Jared share with you today are of interest, you can visit that QR code and get a copy of the queries shared and then run them inside your own environment. Without further ado, I am going to hand off to Jared to get us started. Jared?
Perfect. Thanks, TJ. Thanks everyone for joining. So just walking through our agenda. So today we're going to focus mainly on assets and where assets are consumed in the platform. So first we'll do a quick level set on what are assets, how are they collected, where are they used. We'll give a brief review of what we have with policies. Policies has been out for a long time in the classic version of CloudHealth, but just a refresher on kind of the power of that automation. We'll spend most of our time today in Asset Explorer, where I'll kind of highlight the value, the way we store assets differently, talk about our topology, and then BJ will go through different use cases on how you can optimize resources, save money, identify unattached. And then finally, we'll talk a little bit about AI and how AI can help you author these queries in a more efficient way. And then at the end, we'll go through some of the roadmap items that we're going to be delivering over the rest of this year. Okay, so what are assets? So assets are really any deployable resource in the public cloud. We normalized services and resources and the different things that the different cloud providers call them into one unified structure called assets. And the best way to think about this is for each asset, we do a describe call to the assets API. And then we store the entirety of that describe call in most cases. So if you ever wanted to look at the metadata associated with the resource, the deployment, the relationships between your resources, that is all contained within our asset reports and within our Graph Explorer. Now, assets can live and die on the order of minutes, not days and months. And so for that reason, we have a separate collection pipeline. So your bill, depending on your size, will collect anywhere from once a day to twice a day, and all your reports will calculate over the next few hours. For assets, we actually collect every 15 minutes to every 24 hours. This allows us to collect and model resources that are short-lived. So you won't be missing EC2 instances that live and die within half an hour because we collect them every 15 minutes. And then some examples of asset types. We currently support over 150 across Azure, GCP, and AWS. And again, just really any deployable resource. So some of the big ones, EC2, GKE, Azure Managed Disk, all of the big service categories are represented within the Graph Explorer. So assets are kind of most visible on the asset pages or in the new experience on the graph. But the reality is assets are consumed by lots of different parts of the platform. So perspectives, the ability to group assets and their costs into like buckets, and then report on those different buckets. That utilizes asset data from the past 13 periods, and constructing those fine-grained buckets would not be possible without the asset metadata. Policy, we'll talk about this in more detail in a second, but the ability to evaluate Boolean operations against assets and metadata, again, is only possible because we actually collect and store the granular metadata for each asset in your public cloud. Right sizing, anyone can right size a resource based on metrics and cost, right? Where we excel is bringing in some of the additional metadata to the right sizing recommendations. So what if we wanted to say limit to within the same generation, or don't recommend cross family, or look at the architecture of my VM and look for accelerated network or accelerated disk. We have the opportunity to do that because we collect all those details through asset collection. And then finally, statement drill downs. How do we actually construct a transaction level line item view per resource? This gives you the ability to look at cost per resource ID. You can group by billing operation and product name. basically you can open your CUR or your billing file within the platform because we can correlate it based on the asset metadata we collect. Okay. All right. So now we're going to hop into a live demo. So we'll start with policy and then we'll jump over to assets. So right now we're in the CloudHealth Classic platform. Policy is not quite available in the new experience yet. We will be talking about that more at the end. But here you can see under policy, I have the ability to select a resource type. Now within resource type, you can see all of the different assets that we collect and process, model, and the metadata against them. So this is where we really differentiate as a cloud cost management tool. We are the only one with this breadth of policy, and that is only possible because of the assets we collect. Now, each one of these resources has its own set of policy actions. And so if I were to select EBS volume, I can start to add conditions to check either the cost, configuration, usage, performance, or security of the resource. And so I can look at things like usage. If I wanted to look at unattached volumes that were unattached for more than 5 weeks, I could then save that condition. And then by going to actions, have the ability to create a snapshot, delete the volume, run a Lambda function for further automation, or just provide notifications over email and Slack, notifying the engineer or the owner of the resource to go and take action. And again, depending on the resource you select, you'll have access to different types of policies. So for virtual machines, we can stop and start an instance. We could terminate the instance and decommission it. You have a lot of options here to kind of manage your resource deployments and alongside your tags. So each resource also has a missing tag policy that you can use to kind of keep up to date with your tag hygiene. Okay. All right. Excuse me. Now let's talk a little bit about the new experience. So what you're looking at here is only available in the CloudHealth new experience. If this interface is not something you're familiar with, I recommend you reach out to your account team or your partner and talk about how you can get this enabled for your tenant. What you're looking at here is the new version of asset reports. So in classic CloudHealth, your asset reports are static tabular views that you can export, you can look at the metadata, but they're not very interactive. Now, what we've done in the new experience is model everything in such a way that you can query the metadata and traverse the relationships of your resources. So in a practical sense, what does that look like? Here I can see I've drilled into EC2, and now I can see all of the entity types modeled under EC2. By selecting EC2 instance, now you can see all of the metadata associated with the instance. By clicking Manage Columns, you can see there's additional fields that we store but aren't there by default. You have the ability to hover over these and get tooltips, and then sort these columns in different ways. Now, if I drill into a specific resource, I can actually look at the application topology view. So we talked about relationship traversal early on. This is how we model that. So you can see the arrows are indicating upstream and downstream dependencies. This is really useful if I wanted to action on a right sizing recommendation or change the configuration of my instance. So maybe I wanted to delete this instance. Well, if I do, I need to know that there's potential to orphan a volume, or there's a potential that a VPC subnet would be empty, or the security group might be empty if this was the only EC2 instance involved in it. Okay. And so it's important that before we take action, we actually look at the topology of our applications and understand what is the blast radius of doing something. Now, again, because we model the relationships of a resource and all of the metadata, that translates in the ability to author queries. And so whereas before you were stuck, adding filters, dragging columns into the report, now you can get much more robust. So you can see we support different types of operators. You can evaluate where conditions are true based on metadata. You can search for null fields. You can query your tags. To orient you with a little bit with the structure and the syntax, everything in the new experience is an entity. And those entities are kind of the atomic building blocks of the public cloud. And so you can see we have different entity types based on the provider, AWS, Azure, and GCP. Entity fields are attributes that are common across all entities. So cloud account ID, creation time, region, these are common fields that will be available no matter the resource. Now, if I start to drill in and select something like EC2, you can see all of the different things modeled under EC2. Again, if I select instance, again, now you can see we have access to more operators and see we still have the entity fields. If I add the has operator, now the properties are available. So where entity fields are common across all entities, properties are specific to the entity you have selected. So things like public IP, private IP, platform, architecture, token information, all of this is specific to EC2 instances and therefore contained within the attribute or the properties, I should say, rather than the fields. Okay. So with that, I'm going to hand it over to VJ, and VJ is going to walk you through um, looking for orphaned, idle, unattached, wasted resources, talk you through some of the FinOps use cases, and really dive deep on how you can use the query syntax to save money.
Thank you, Jared. So let me share my screen. So I want to kick us off with a few examples on how we can optimize our cloud environment. In this demo, I'm going to jump between a few entity types. I'm going to jump between Azure, GCP, AWS. I'm also going to jump between different types of infrastructure like serverless storage, just to show us the breadth of what we could do. But any examples I show is translatable to the other type. So like there's nothing special about like one type versus the other. It's just I'm going to like demonstrate them because we can find like more use cases from more customers if you're like AWS, Azure, or GCP. So let us kick it off with public S3 buckets. So why is this important? Because public S3 buckets have the tendency to accrue cost. There's like some reasons why we want some S3 buckets to be public, but we can only find that out via like an intricate combination of ACLs, bucket access policies. But here we have like a simple Boolean that you could just like query on, which is like true or false. When it comes to properties, properties come in different types. They're like Boolean type, string type, date type. So we are gonna like look at all the types, and like with some examples. So this is a type where like is public accessible is a Boolean type, so we could say is true, and then we get all the buckets. If we want false, we could do false. We could also do so the other thing we could do is whenever there's an equals, we can do a not equals. In this case, this just becomes for a Boolean operator the opposite of not equals, which is true. But you'll see in like string and other examples where this is more useful. So you can find public S3 buckets, audit them, and then like make sure if they're actually like required to be public or not. Um, and the next example I want to dive into is find uh, IP like instances which are not running but which have a public IP address. So why is this important? So public AWS, I think like a year ago started charging for like public IP addresses. So instances that you have which are not running, which have a public IP, are good places to optimize and save cost. I want to talk about this specific structure. So as you can see, I have this special underscore null underscore. So what this means is we want to know if a property is null or not. AWS first does not provide strings, or there could be empty strings, or they could be nulls. So if you want to identify nulls, this is the property that you want to use. If you say equals nulls, it'll find all like the same thing as before. There's a string property, and like when you say equals nulls, like you'll not find public IP addresses. If I say public IP, you will see that they're like null. And if I do not null, you'll see a value. So the next piece is this strange like bracket. So what this means is this is considering this as an array. It'll like not, this just means the state is not equal to one of these. If you want specifically, you want like just like not equals to running, you can find them. I just don't have an example here, but I could like find another example. Not equals to terminated. So you're going to see a lot more instances now. So this is an example on how you could do like string operators. You could do equals, not equals, and we could do like not in one of these operations. So the next example I want to show us too is an integer operator. So size in gigabytes is an integer, so we can perform equal to, greater than, lesser than for an integer. So this is a query where the volume has more than 100 gigs of data, and it's a GP2. GP2 to GP3 is a very easy migration in a lot of cases, and it's bound to have like more performance and lesser of a cost impact. So these volumes are prime for migration. There's in most cases there shouldn't be like any downsides to doing this migration. So this is an example of like a no downsides migration. The other thing I want to show us is you might have seen that I clicked the example and there was like it says one account selected here. So any of the queries you can use this filter to like select one or more of the accounts. Let me select a few just to show an example. So you could run these queries for one account, you could run these queries for a couple of accounts, or you could run these queries for all accounts. And some of you might be wondering how I got them in saved queries. For that, you can like define all your filters, click on save here, type a name, and then once you click save, it's gonna save it, and then you can like reuse them. So these were three examples of like storage, compute, optimization. So the next thing I wanna jump onto is a serverless optimization. So this is the default configuration for AWS Lambdas. And we've seen like cases where default configurations are not always the best. When like the out-of-box configuration, they're just meant for like the widest possible support group for easy running. So you can find these and say, hey, these are default configurations. Are we sure we want to optimize it? Are we sure this is optimized? And we can find examples and fine tune them. So again, this is not just limited to this. So there's like other properties that you can like find for like serverless. You have all these. Let's say you want to find, for example, a specific instance that's like on a specific runtime. You can do that. You can also find like, for example, if you want to find runtimes and versions, you can also do that too. So the possibilities here are endless, like how you want to exactly optimize. The other thing I want to point us to is this very helpful like error message. It says incomplete query. What this means is we're not going to be able to run a query. So you're not going to have the situation where you run an invalid query and then get an empty response, because you will not have you'll not be able to run invalid query. So it's going to tell you exactly it's an invalid query and then give you helpful suggestions. So the next thing I want to talk about is like we all like talk about AI. So this is an example where we have a notebook instance. So this, excuse me, this is an example where we have a date operator. So what is a date operator? So anytime we want to find, operate on dates, in this case, last modified time, we can use days ago, months ago, or years ago, and you can specify a number. So you don't have to worry about like string operations or how this is formatted. That's all taken care. So why is date operations important? You could ask me. In this example, we have SageMaker notebook instances that have been in service, and the last modified is more than 15 days ago. So these notebook instances could be shut down, like could be spun back up later. So if they're not in constant use, and like these instances in most cases become like very expensive, because like machine learning models and like when we train machine learning models, we want like the best in breed, so we can get the best models or train the best models or like optimize them in the way we specifically want. But like, when it's not used, we can always shut them down and save money. Another example is DynamoDB. This is an example of an in alpha configuration where we have more read provision units than we have item counts. So, like this is like a integer operator that we've seen before, but I would just want to show you this because like DynamoDB, if you have multiple, I wouldn't say this completely doesn't make sense because like this would make sense in the case where like we have one table where we have multiple like consumers, but the chances of that are, I wouldn't say like not in the majority. So this is a case where we can optimize and save money because provision read units cost money because like they're like provisioned already. So it's not like a dynamic. So you could just drop this down to like something like, right size this is like, and find instances that we can right size. So we've talked a lot about queries and like how we can find queries within a specific instance type. What I want to drive us towards now is relationships. So what are relationships? Relationships are when Jared showed us like the graph view, they are relationships. So we can also query them. So the way to query them is you have one instance type and you have this specific operator. I can remove them and show. So you put a dash and then like, you have this helpful autocomplete. So you could do GCP dot compute dot attach disk. So this is the view on how you'll get a relationship. So you'll have source properties and destination properties. So you will see which entity type this property belongs to. You can do you can see like, can this forward, can IP forward, like properties like that. And you can also see them in destination properties and what are the licenses. So you will see them on both sides, and you could like do operations. So what do I mean by telling you that like we can do operations? Um, we could say, hey, I want EC2 instances that have an auto scaling group that has auto scaling that does not have an auto scaling group policy. So this is an example where you can like filter specifically from the right side. You can apply filters. I'll show you an example of like how we can do it on the left side too. But here, this is just attached to like an auto scaling policy, but we don't have the has auto scaling policy 0, which means like we don't have an auto scaling policy. We just have an ASG. These are prime for optimization because like if we have like there, I wouldn't say there's like no use case for this, but like in a majority of cases, when we have an auto scaling group, we want to scale down because like depending on the load, if it was a web server, we want to like scale based on the load. If it's like a cron, we could scale based on like when the cron is supposed to execute. If we have a queue-based workload, we can like I guess like have ASGs based on like queues. So like based on different workloads, you could just like scale down your instance. That's gonna like save money there. So you can find instances like that. Um, so this is an example where this is a not equals operator. So just like how I mentioned equals, you could do a not equals. And what it's going to do is it's going to like find relationships that are not related. So this is an example where EC2 instances are not related to an elastic load balancer, which means they don't have a load balancer in front of them. So you can find web servers like this, and they're like prime for optimization. We can go to load balancer, and then they have like, since they're like ephemeral loads or most instances are meant to be ephemeral loads, this could find instances where like we can optimize those instances. And like after all this, you could ask me, hey, you haven't talked about like tags, what gives? So anytime you want to perform tag operations, you could do a tag dot. It is the same as properties. Anything that I've talked about so far applies to tags. So you could do an equals operator, a not equals operator. You could do a null, not null, and everything works for tags. So this is an example where we have a VM that does not have a cost center tag that does not belong to a VM scale set. So why is this important? When like even I have been guilty of this, where I've spun up like an EC2 instance, but I don't or might have forgotten to put a tag on it or a specific tag that my organization tracks for cost allocation. So this is an example where like if we don't apply a cost center, it does not have a scale set, it will always be up, ergo we'll always be paying cost for it when we don't need to. So this is also like your compliance where like you can like for tag compliance or like you can like resource optimization, you can find instances like this. Um, So this is a little bit about relationships. So we've talked about tags so far and relationships so far. The other thing I want to point out about relationships, the last thing I'll say is we can also do like accounts in relationships. You could do like you can select accounts, you can run relationships. So any query you want to run here, you can always scope them down by accounts. So the last thing I want to talk towards is aggregation. So what is aggregation? There's like in a lot of cases, we are happy to find relationships, but there are like cases where we want to find specifically the count. How many of us wanted to find, hey, how much is, how many instances am I running in this account? So for queries like that, that's where I'm sorry, aggregation comes in. So this is an example where EC2 instances count by state. So I have at this point in time, I have like two instances in pending, 5,000 X instances in um, running state and like these states. So why is this important? Why do I need to see aggregation outside of like I just want to count? I'm glad you asked the question because we have several examples where this is an example where we can find how many load balancers are internet facing versus how many load balancers are internal facing. And this is scoped by a specific account. So what this does is you can go in and like you could have a bunch of like dev accounts that have internet facing load balancers and find out why they exist. Like why does dev accounts have internet facing load balancers? It could be a very legitimate use case where like we want to access certain things, but find out why they exist or even know they exist um is a win for optimization. So how do we find out like what these are? Like I don't want to like you could type in has properties equals interface. You can do all that, but you can also click on this, and then it will be auto-populated with what you click, and then you will specifically see the instances that you're interested in, or in this case, like load balancers. Um, so here's another example where for SQL databases, this is not always the case, but like in more cases than a few, I've seen instances where there's a workload that runs in premium that for some reason when we had to do a migration, when we had like to do like a big change, we needed premium tier. But once they hit their normal level operations, they could be moved down to like a standard tier and like optimize those instances like that. So this is like, cases where you can use aggregation. But I saved my favorite case for last, which is how I personally write these queries is I don't first start out and like just type properties, which we can always do. But what I do is I always start out my query building with aggregation because like, when I start with this, I want to like, when I'm in an exploration phase, I'm like, hey, I want like, OS this type. So I click on this. And what I do is the next thing I do is, like I know this type, but what I can do is even with this like property filters, I can do a count properties dot. And what will happen is you will see an autocomplete pop up and you could select specific other properties that you're looking for. And then you can click on run and then you will see like aggregation performed with filters. And then if you want, you can do accounts too. But like, I could do this and then say, hey, state is successful. And then I could like I could keep going on. So just for fun, I'll do one more. Let's find a good one. Maybe caching, sure. cache rewrites. So if you have more than a few, it's gonna like show you more than a few. You could do this, and then at the end, let's do regen. See? So you can keep doing this, and then you can keep building your query. Now, suddenly, like I started from like a simpler query, used aggregation, and then like started building more queries. At any point, you could do not equals, you could do like an in operator, like with brackets. So the possibilities are endless, like how you want to query your cloud environment. So that's query building. It wouldn't be a webinar without talking about AI, and I guess in like 2026. So we like sometimes like this I know how to like write queries, or like I'm very comfortable is a better word to use to write queries. But sometimes I don't want to like spend the time to write queries. I just know what I want. I just want to get it. In those cases, we have we have intelligent assist. So intelligent assist is right here to help you with your query needs. You can use this as a jumping off point, or you can use this to find specific needs that you want to find. So working back to the first example, I could say find all S3 buckets which are public. So intelligent assist, what it's going to do is it knows about what you mean when you say S3 buckets or EC2 instances. It knows what you mean when you say public. You don't have to specifically tell it to like find is publicly accessible true or not. You wanna talk to it like you talk to like someone, or like send a text to someone, and then it's gonna figure out how to like get your specific query and then like resolve it. In my case, I said like S3 buckets public, and then it was able to find like it was able to find, hey, is as public is public, it maps to like what property, and it's able to query and give you some examples. So this is like how you can use AI to like search for specific queries. With that, I will pass it on back to Jared.
Perfect. Thanks, Vijay. So, talking a little bit about future state. So, um, the Graph Explorer has been out for about a year. And these are kind of the five main areas that we are focusing on improvement going into this first half. So the first one is we need to increase asset support across the board. So while we do collect a good portion of the assets, over 150, there are still some missing from the database that we need to add support for. The first ones that we're working on right now are Azure and AWS serverless. So we're in the process of adding support for Azure Container Apps, Azure Function Apps, and then looking at Aurora serverless for AWS. AI AssetQL generation. So Vijay talked a little bit about AI and how that can help you construct a query. Today, the output of that query is limited to a list. We want to take that one step further and have AI do actual generation of the query itself. So rather than getting a list of EBS volumes, you would get the actual underlying query generated for you, and AI can help kind of co-author that as you go. Improve syntax and operators. So one of the barriers to entry, I would say, for the Graph Explorer is the need to learn a new syntax. And so we want to invest a lot in the user experience and how we make constructing queries easier. How do we give you more operators to represent the data in a way that makes sense? So we're looking at two things: multi-count, which is the ability to do the aggregation queries that Vijay showed by multiple properties. So count first by license type, then by generation, for example. Sort, exactly what it sounds like. You can enforce sort in the UI, but you can't yet use sort operators within the syntax. So giving you more fine-grained control over the output of the query. Asset effective costs, really excited about this one. So the top 20 resources by count and spend for AWS and Azure will be coming out this month. You will be getting the hourly cost and projected cost per resource directly in the graph view. So if you think about a lot of the queries that Vijay showed you, the next step is giving you a cost lens on what you could save by actioning on it. So I have a list of unattached EBS volumes. Well, now we can show you the cost per month and the hourly cost for that resource. And then finally, policy and notifications. When we talked about policy earlier, while it is powerful, you were still gated by CloudHealth engineering onboarding a resource to that engine. Now in the new experience, in the graph, as you saw, you can evaluate any Boolean condition on any resources, metadata, or relationship that you want, right? So you can think of this as policy as code. Now, the next step is to add a notification service and different policy actions into the graph. That way you could say, show me all unattached DBS volumes, and also notify Jared every time this query finds new results, right? So trying to bring policy and asset reports even closer together is one of our key areas of investment for the year.
Thank you, Jared. Thank you, Vijay. As I said at the top of the call, thank you all for joining us to start off 2026. Appreciate you spending some time this morning, this afternoon with us. Also, as I mentioned, the QR code on your screen will link to our Cloud Health community. All of the queries that both Jared and Vijay shared with us today are available now on the Cloud Health community page. Please join that to stay on top of our latest and greatest feature enhancements, on top flex reports or queries, as well as any news and upcoming events and notes, as we will have more of these webinars going forward. Thank you all for the time, and I appreciate you joining us. Thanks.